we discuss three important and interesting problems of complex number of JEE standard. Okay, now the first one is, if the cube root of unity are 1 omega omega square, then the roots of the equation x minus 1 whole cube plus 8 this is equal to 0 are. Four options are given here. We have to find the correct alternative. We first say that the value of 1 to the power 1/3 are 1 omega omega square. So the value of minus 1 to the power 1/3, this is also minus 1 minus omega square. Okay, we use this result here. Now from this equation, x minus 1 whole cube, this is equal to minus 8. So x minus 1, this is equal to minus 8 whole to the power 1/3, and this is 2 into minus 1 whole to the power 1/3. And so this is 2 into minus 1, the first one, 2 into minus omega, this is the second one, and 2 into minus omega square, this is the third one. So x, this is equal to 1 minus 2, 1 minus 2 omega, 1 minus 2 omega square, and this is minus 1, 1 minus 2 omega, 1 minus 2 omega square. Okay, so it is very easy to verify that the D is the correct answer. Okay, and this is very important result we use in different problem of complex number. Second one is the minimum value of mod a plus b omega plus c omega square, where a, b, c are all not equal integers. Okay, not equal integers. This is very important word. And omega is a cube root of unity is. Four options are given. That is, we have to find the minimum value of this expression. Now here we apply the property of complex number. This is mod z square, this is equal to z into z bar. And also we know that omega bar, this is equal to omega square, and obviously omega square bar, this is equal to omega. This property we apply here. And also we apply here an important factorization which is very important for complex number. This is given by aq plus bq plus cq minus 3abc. This is equal to a plus b plus c into a square plus b square plus c square minus ab minus bc minus ca, and this is equal to a plus b plus c into a plus b omega plus c omega square into a plus b omega square plus c omega. Okay, we write this factorization. Now we let a plus b omega plus c omega square whole square. This is equal to a plus b omega plus c omega square into a plus b omega plus c omega square whole bar. And we know that this is a plus b omega plus c omega square into a bar plus b bar omega bar plus c bar omega square bar. Since a, b, c are integer, so obviously this is a real number, and we know that omega bar, this is equal to omega square, and this is omega. So we get a plus b omega plus c omega square into a plus b omega square plus c omega. Okay, and this is equal to, we know from this factorization, this is equal to a square plus b square plus c square minus ab minus bc minus ca, and we know that this is half into a minus b whole square, b minus c whole square plus c minus a whole square. Okay, here it is given that ABC all are not equal integer. Now for the minimum value of this expression, we must have to take a, this is equal to 1, b, this is equal to 0, and c, this is equal to 0. Otherwise we maybe take a, this is equal to 0, b, this is equal to 1, or c, this is equal to 0, and so on. And so clearly the minimum value of this expression is 1 plus 1, because if anyone we take 1 and otherwise 2 or 0, then we get 2 1 from this, and this is into half, so this is 1. Now the minimum value of the expression a plus b omega plus c omega square, this is equal to root 1, this is equal to 1. So our correct option is option A. And the last one is, if omega not equal to 1 be the cube root of unity, and 1 plus omega square whole to the power n, this is equal to 1 plus omega to the power 4 whole to the power n, then least positive value of n is. 4 options are given. This is very easy problem. We know that 1 plus omega square, this is equal to 0. This is the property of cube root of unity. So 1 plus omega square, this is equal to minus omega, and 1 plus omega, this is equal to minus omega square. Put these two value in this expression, we get minus omega whole to the power n, this is equal to 1 plus omega to the power 4, so this is 1 plus omega whole to the power n, because omega to the power 4, this is equal to omega cube into omega, this is equal to omega, because omega cube, this is equal to 1 also. And so minus 1 to the power n into omega to the power n, this is equal to minus omega square to the power n, so minus 1 to the power n omega to the power n, this is equal to minus 1 to the power n omega to the power 2n, and this minus 1 to the power n cancel out from the both sides, and we get omega to the power 2n minus n, this is equal to 1, so omega to the power n, that is n equal to 3, because we know that for the least value of n, omega q, this is equal to 1. That is our correct option is option